So, question 2a. The question says, if two proportions A and B are such that the probability of B and A is equals to the probability of B. So we are asked to demonstrate whether they are independent of each other. So that is what we're going to do here. So we want to look at that. So before we do that, given that the probability of B and A is equals to B, we will rewrite the conditional probability that the probability of A and B is equals to the probability of B and probability of A multiplied by probability of A. So we'll have probability of B to equals to this. So from there we can also check our event to know whether it is independent or not. So let's go to the working. So these are the steps to go in order to arrive at the desired condition to prove this event to be independent. So to demonstrate, we have to consider, number one, you look at this. You consider this, that eventually we have the probability of B and A is equal to probability of BA over probability of A. So from here we can rearrange this equation. We have this. So when you do a cross multiplication, this will give you this. You are going to have this. So the probability of B comma A will equals to the probability of B condition A multiplied by probability of A. So now if the conditional probability of A and B is equals to probability of B, we can substitute it into the equation. So anywhere you see the probability of B condition A, you are going to put probability of B in. So therefore it will give us this, that the probability of B and A is equal to probability of B and perhaps multiplied by probability of A. This equation states that the joint probability of A and B, that is probability of B and A, is equal to the product of their individual probability. That is the definition of this, that the probability of the joint probability of A and B is equal to the product of the probability of B and A. So conditionally, if two events A and B are independent, independent means that there is no intercept between two events, that is eating and baiting, or you say there's an event sleeping and driving. This event, moreover, sometimes they are independent to each other. That is why you see there are consequences when you carry out that event. So any event that is independent does not have any similarities. So if the two events are independent, the joint probability, that is probability of B and A, is equal to the product of their marginal probabilities. Probability of B, which is this, and the probability of A. Therefore, from the equation which we have from here, probability of A and B is equal to probability of B and probability of A. So we can conclude that the conditional probability of B and A is equal to probability of B. That is, A and B are independent. Hence, if two proportions A and B satisfy this condition, they are independent of each other. That means that one will be 0 and other one will be a very reasonable probability. So what it means that the probability that someone can drive and sleep, so is it that the person drives or the person sleep? So you are going to pick one. So you can't do that. Or they say eating and baiting. So it's either you do one and leave one. So if one is having a probability the other one will be 0. So one will be 0. So we cannot have an event that said the probability of baiting, someone baiting at the same time and also eating will be able to give you a reasonable probability. That means that that probability is not substantial. So what it means that when one exists, the other one will be 0. That is independent of what? Probability. But when it's a dependent probability, there is going to be what we call it an intercept between the two events. So that is the establishment of the particular event which was asked in question 2A. Thank you.